In this video, we're going to learn about how Tool 4 works. Tool 4 is a region that identifies color portions and color ranges within the selected area, and also provides features so we can perform dynamic work processing and more precise color relation within the selected area. First, let's open the camera here. The camera module will make the connection. We can see here the image of a metal factory where we have the output of the production, the video. We'll repeat at certain moments, where we can see that at a certain point A, small fire in the area where I'm hovering the mouse. The idea of Region 4 is to try to identify this fire and alert through the observed colors. Initially, Tool 4 is observed down here as we can see here it has up to 5 regions I can select. Region 1 here, just above in the video. We can see that in this area here, a small fire occurred, and this is where we will analyze with the Tool 4. First, to identify the colors in this area where it occurred, we'll use a tool called a histogram of colors, which is this tool here that we'll generally use along with Region 4. Let's click here on the histogram. When we click on the histogram, we observe that the same video shown in the module is the same video shown in the histogram. When we click on the video, we can draw a ROI on it. By rotating this ROI, we can place the ROI within the selected area where we'll analyze. In this case, it will be this region. Once we open the video, it starts being recorded in memory, and we can identify all the movement that occurred here. As we can see, the fire already occurred. This way, we can pause and identify what happened in the color histogram at the moment the fire happened. Down here, we can maneuver the mouse to the region where the fire occurred. This region, and here we can observe what changed in relation to the others. When there was no fire and when there is fire. We can observe that there was an excitation in this region at the beginning of the spectrum. Since the value is very low, it's hard to observe, so let's zoom in on the scale. Set it to 20% of the scale. Let's set it to maximum fire. No fire. Max fire. No fire. We observe that the affected region is the lowest region. Let's do it again. No fire. Fire started to occur. And here we observe the fire. As we can see, there's a station there. In this region, we can click here on the double click, where I can select the region I want to analyze here. And see what happened here. Here, the number of pixels within this region of colors. That is, the region we selected here at this moment. 2.7% of the pixels are in this color range in HSV from 7 degrees to 27 degrees. Let's analyze more deeply. When burning. When there's no fire. When there's fire, we can observe here that it reaches 2. When there's no fire, it's below 2. We can identify other regions in parallel as well to make the diagnosis more accurate. However, it requires more studies. But we've already discovered that we pick a similar ROI. Above 2, we have a fire characteristic in this region. Let's keep the histogram here and go back to the main screen. Video here, I can't pause it. It's the video that's actually being filmed. I pick the drawing. I can place a ROI exactly the same size as the one I placed there. The closer, the better. Values stay similar. I rotate the selected region and insert my analysis region. As here, I could identify that there's an increase in the H value from 7 to 27 degrees. So, let's do the same here. From 7 to 27 degrees. We'll leave the S and V scales full for this test, which is from 0 to 100. We can work with the S and V scales here too, because here we have the average and maximum of each, where we can see before and after the fire, and make our filter even better. But in our case, we'll work only with the H value and leave the entire band of S and V. Once done, I turn it on. And here I have the same characteristics as the other regions. The drawing region where I drew the start, stop, A, momentary analysis, and Gaussian filters. Or bilateral, in case my camera has some instability or noise. Image. In our case, we'll start the analysis here. We can observe here that the range is larger compared to the analysis because our ROI is not exactly in the same place as the histogram, but we have an idea of the range to be analyzed. Wait for the spark. We can see here that it reached up to 9%. This area's pixels. In this range, it reached up to 9%. Here we can set an alarm above 7%. This effective output here might indicate fire. I can send this output to my PLC, to my email, to my supervisory system. Wait for fire. It'll show here. I can analyze up to 3 different colors. You see? That here I put in the final result. The final result is nothing more than the sum of all 3 colors. Since I don't have color 2 and color 3, my result is the same as my color 1. So I'll put 7 here as well. Right below here, I have the moving average of the obtained value in the last 10 measurements. For example, in the last 10 measurements that I selected here, I can change this value. I had an average now around 6% and 7% because the fire occurred up there. Let's let it stabilize again. I have here a moving average of 2. I can set a value here if I exceed 2% of this average. Then the dynamic output value will be 1. The same thing down here. Because I'm using color 1. Let's wait for the fire. When the fire occurs, we can observe down here by the configuration we made here that both these 2 values will be positive, and these 2 moving average values here will be positive too. Wait for the fire. Positive and positive when the fire was out. It went to 0. With these values obtained here, we can send the data as mentioned before to the entire transmission output, to both Modbus and API and CSV files. Remembering that in this case, we applied a filter to only 1 color. We can apply filters to 2 more colors by filling out the rest of the analysis lines, making our filter much better with improved diagnostic capability. Remembering that all these outputs in gray are possible again. Our output, where we can select the variable here, in our case, region 4A, where I have types of output percentage and logical outcomes. Remembering that we can identify what each of these outputs is here in the manual. This way, we can filter fire detection in a production output. As we can see, we can perform various types of color identification for various types of different applications, whether for security or production. Color identification in any type of application, even when there is movement in the image accurately. This way, we conclude the lesson related to Tool 4. Remember, the manual has the correct and explains each item in detail.